So area of a rectangle. When we want to find the area of a rectangle, we multiply the base times the height, or sometimes you'll hear it called the length times the width. Now, when we get that answer, so 9 times 2, this would be 18. When we get that answer, we always do it in square units. I'm wondering if anybody's ever explained to you, first off, a thumb or a hand, something. Does that sound familiar? Getting area, getting square units? Yes? All right. Did anybody ever explain to you why we do it in square units? No? All right. And that's one of the things that happens sometimes in math is we give you something, we tell you, hey, make it square units, but we don't really tell you the why. So let me show you the why. Would you take a line and would you divide that rectangle in half? Now you'll notice my half isn't perfect, but that's all right. It's going to be close enough for the work we're doing. And at this end where I extended the line beyond the rectangle, put a couple of ones because we have this whole length of the side is 2 feet, so each of those little pieces is 1 foot. Then we're going to do the same thing dividing it up and down. So if this were an even number, we would find exactly half. It's not even, so we're going to go just a little past half and draw a line up and then divide that part of our rectangle in half. Each of those, because that's the 4-foot section, and then keep going for the other 5 feet. So you're going to end up with 9 sections here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now again, if you look carefully at mine, I did not get them perfect, but that's all right. In each of these, put another 1, because each of those is a 1-foot section. Hey Tyson, good to see you. So now what you'll see is that we've divided this up into 18 pieces, and each of those pieces is 1 foot by 1 foot. It's a 1 foot by 1 foot square. And that's where we get this idea of square feet. So, rectangle, length times width. The length, 2. Which we might also call the base, the width, which you might sometimes see called the height. And in fact, if you get used to calling it base and height, it actually works better when you get to triangles. And so let's get to triangles. Now, any place along the way here, because I'm concentrating on this, what I'm writing for you, and the talking, and I'm not, and scratching my ankle right now, and so I'm not necessarily seeing if you raise a hand. So if you have a question, feel free to go ahead and unmute your mic and ask. Hey, Jose Bravo, I didn't see you jump in the room. Nice to have you here. Still hoping that Mr. Bustamante shows up. All right, when we do a triangle, let me zoom out just a little bit. When we do a triangle, it's also the base times height, but then we divide that answer by 2. And let me show you why we do that with a triangle. What I'd like you to do is I'd like you to draw this triangle. I'm going to pause for just a minute. Draw this triangle, a right triangle, 8 centimeters tall, and with a base of 6 centimeters. So a height of 8, base of 6. Then what I want you to do is I want you to complete a rectangle around this. So we're going to draw a dashed line up this side. That dashed line is also 8 centimeters tall. And we're going to draw a dashed line along the top. That dashed line is 6 centimeters wide. And notice now we have a rectangle that's 8 by 6. If we wanted its area, we would say multiply the 8 times the 6 and get 48. That would be, let me just highlight it here. That would be if I was doing this whole rectangle. That would be this. But I'm not really doing a whole rectangle. How much of the rectangle am I doing? If I have this triangle, how much of the rectangle do I have?
Half?
I have half of it, exactly. And that's why when we're trying to find the triangle, we would take this and we would divide by 2, which would give us square centimeters. It's always in square units. And that amount shows us what's the actual triangle. So rectangle, length times width, or base times height. Triangle, base times height, and then divide it by 2. And then last, for perimeter, it doesn't matter what the figure is. Perimeter is where you measure all the way around it. So let's say I wanted the perimeter of this rectangle. I would pick a starting spot, like this upper corner, and then I would ask myself, if I was measuring all the way around it, if I was going down that edge, across the bottom, up the side, and back to my starting point, how far did I go? Well, I went 2 feet, then 9 more feet, 2 more feet, 9 more feet. 9 plus 2 is 11. Another 9 plus 2 is another 11. I went 22 feet. It's the very same if I'm doing a triangle. Pick a starting spot and then trace your way around it. 10 feet plus 6 more is 16, plus 8 more. I would have traveled a total of 24. 10 feet plus 6 plus 8. The perimeter, the distance around, would be 24. All right, I'm going to pause for a minute, let you catch up on notes, and then we will try some of the problems you're going to have for homework. Let's go to a problem to practice. Would you go ahead and take this first rectangle right here and find its area and perimeter? 6 centimeters by 3 centimeters. Calculate the area and the perimeter. Let's take a look at this one. So for the area, the distance inside, that's what area is. All of this space inside here is the area. It would be 6 times 3 for a total of 18, and we would put that in square centimeters. So 18 square centimeters. For the perimeter of this one, we would start in a corner, and we would think of going all the way around the figure. Now, something that a lot of students in the past have found helpful to avoid making a certain mistake is they actually label these other sides. Because a common mistake is students see the 2 numbers that are shown and they just add those together. They add 3 and 6 and they say it's 9, but they don't complete the other half. So by putting in these numbers on the other sides, we can see that it's 6 plus 3 makes 9, plus 6 is 15, plus 3 more. This has also a perimeter of 18 centimeters. Let's do one more. Go ahead and do this one with the rectangle that's 5 meters. Actually, do the one below. Let's do this one. 5 kilometers by 5 kilometers. Find the area and the perimeter. So for this, the area would be the 5 times the 5. So 25, that describes a space in here, 25 square kilometers. And the reason I picked to have this one is that it's a square, which means you could add all the sides. You could do 5 plus 5 plus 5 plus 5 to get 20. That's the perimeter. Or you could do 5 times 4. Since all the sides in a square are the same length, we could multiply those together. Any questions on rectangles before we move on to triangles? Great. So let's do a triangle problem. And if you would do, let me find one I haven't had students do before. Let's do this one down on the bottom. Would you do this one right here, number 7? You're finding the area and you're finding the perimeter. So draw the triangle and then find those parts. Somebody's got a microphone that's loud. So we have 4 numbers. Let's start with the perimeter on this one. Are we going to use all 4 of these numbers? Or is there any of those numbers we're not going to use? Anyone want to jump in? If we were starting at a certain point on the triangle, let's say we were starting in that corner, and we were finding the perimeter, the distance all the way around, which of those numbers did we not use? You can unmute your mic and chat it. You can text it. Thank you, Grant. Grant correctly said, for finding perimeter, we will not use the 8. It's this line on the inside. It's the height. We're going to need it for area, but we don't need it for perimeter. So for this particular triangle, the perimeter is going to be 10 plus 2 plus 10, or a total of 22 feet. When we do the area, we will need that 8 feet. Let's get rid of all of that excess stuff. Get rid of that. And now we're going to find the area. For this one, the area will be the 2 feet times the 8 feet, the base times the height, and divide that by 2, which will be 16 divided by 2, which will be 8. We have an area of 8 square feet. Now you might look at that and think, well, wait a minute, the height itself was 8. Let me show you a different way to think about writing this. So down in your spiral, write this. Area of triangle. One way to write it is the base times the height divided by 2. A second way to write it is the base times the height times 1/2. Dividing by 2 is the same as multiplying by 1/2. And with multiplication, we can change the order if we want to change the order. So if we did the numbers from this problem, we could do it as 2 times 8 times 1/2, which would be 2 times 8 is 16. And then you'd get 1/2 of 16, which is 8. However, we could also do it as 2 times 1/2 times 8. Multiplication is commutative. We could change the order around. Well, 2 times 1/2 is 1, and then you get 1 times 8. You end up with the same answer. You just get different sub-answers along the way because your sub-problems are different. Let's do one more. Go ahead and do problem number 8 while I clean up some of my work here to make space for 8. Would somebody like to tell us how they found the area of problem number 8? Somebody willing to jump in? Rivaldo, willing to jump in? Everybody's shy about being on the microphone. All right. So for number 8, the base is 4. Sometimes it's helpful to label those. The height is 10. So we're going to have the base times the height, and we're going to divide that by 2. 4 times 10 is 40. We divide that by 2, and we end up with an area of 20 square feet. Get my B for base out of the way. For the perimeter of this triangle, we have a height of 10. We're adding a base of 4. And then we're adding this side that's 12. We call that side, by the way, a hypotenuse, because this is a right triangle. And so we would have 10 plus 4 is 16. 16 and another 12 would be 28 feet. So between now and when we meet Thursday, you have some practice to do on area and perimeter, both rectangles and triangles. Oh, you know what? Somebody pointed out they said they thought I added incorrectly. Let me double check here. Oh, you're absolutely right. I wrote 28. I should have written 26. Somebody's paying attention. Who was that? Who caught my mistake there? Thank you. That's what happens. I don't know why I erased that 12. That was still true. Yeah, sometimes when I'm trying to write and talk and think and all those things at once, sometimes I get one of them wrong. And I hope you'll always do that. I hope you will always correct me if you see me make a mistake on this. I don't want people to think, gosh, there must be some weird new math. Suddenly that totaled 28. Okay, any questions you have for me? If you have a question, you'd like to stay on the call for a minute or two and ask stuff, feel free to do that. You have homework. The homework is sitting in Google Classroom. So if you click these links in the agenda, it will take you right to your classroom page. For me, it brings up all the pages I have. For you, it'll bring up 6th period here with the cool green and the soccer ball. And then in classwork, you will find them right here on the Monday, Tuesday section. Area of rectangles, triangles, perimeter of rectangles, triangles. All right. That's a good stretch, Miles. It's work well done. Anybody have any questions? No questions? All right. It was great having you come to class. I will see you all. I will see you all. I will see you all. I got my screen off to the side of my camera here. Let me stop presenting because now you're just seeing your own faces again.